Hey everyone, this is Vinayak. Now in this video, what we are going to do is we will understand from one device to another device the flow of the data, how data flow one device to another device, each and every device, how behave itself with this data, and each and every concept that we were done in the theory that we are going to be do in this virtual lab. Okay, so what are the things that we might actually know about before doing this lab? So that's some kind of protocol that we have to already aware. So that's ICMP and ARP. So before doing, let me just go and check these all identities of the devices, so which we want to ping to each other. Okay, so the IP config / to check the MAC event, it will also show. So as you can see right here, the IPv4 which is 10.0.02, and the MAC is, this is the way to check. And if I want to check another way, like even I can hover this cursor over this, so that will also show the MAC and the IP address of this device. What about this, the PC9, the in device? There, as you can see, the IP address and MAC address of this device too. We will going to communicate through this device to this device while pinging. What will happen? Let's see. So before pinging, what I will do, I will check the IP address by hovering. Here we have the 30.0.0.4. So I will go into it and I will type 0.0.4. Okay, before pinging, I will switch in simulation mode where we can see the flow of the data. Okay, so again I will hit with enter button. Now as you can see right here, the ICMP initiation and then after ARP initiation, what it is and what's is happening right here. So before the ICMP, there's another thing that we call the AND process, where that will check the target within a single LAN or out of the LAN, within a single network or out of the network. So ICMP is a Internet Control Message Protocol. What it will do, it check the connectivity, it will check the reachability to the device and diagnose the whole network. Okay, so this is a kind of diagnostic tool to check the reachability. So to reach to the destination, the ICMP have need of 4 identities. So the source IP, destination IP, and destination MAC and source MAC. That would be the order. The order should be like this: the source IP, destination IP, then destination IP and source MAC. The destination MAC and the source MAC. Why the destination MAC is coming first? Because as we know, in Ethernet header specifically, when we break down, so that we see the preamble, then after SFD, then after the destination, then source, and in between that we also see the tag, which is VLAN 10. So it has the tag of .1q. So in between the destination and type, we see also the tag of A22.1q, which is the VLAN tag. And this is what we see, the order, the destination and source thereafter of the MAC destination and the MAC source MAC. Okay, so if in case we have the source IP, destination IP, and the source MAC only, and there's nothing about the destination, which is the PC9 MAC address, so ICMP will hold itself until it will know the ARP, the MAC address, the destination MAC address of this device. So once it will know, thereafter it will initiate the process. So to bring the MAC of this PC9, it will send the next process, the ARP process, that we call the address resolution process, address resolution protocol. This is the process to get the MAC address of destination IP. Okay, so what it will do, let's see. Now as you can see, it's a broadcasting address instead the MAC address of that device. If the destination IP is out of the LAN, so it will firstly it will target the, what about this IP 10.0.01? As you can see, this is the gateway IP, and what we see, instead targeting in ICMP we have seen the target, the destination IP was 30.0.4, but what we see in ARP, it will work in within a single LAN. So it's targeting the gateway first. Okay, so the destination IP, as you can see, 10.0.0.1. So it will make target the destination IP first. Okay, within one single LAN, it will broadcast, and the switch, the behavior of switch is broadcasting. So let's see what happened. Okay, as you can see, it's reaching to the switch, and the behavior of switch is broadcasting. So it will broadcast, and it will also learn the MAC address of the PC1, because of it will nothing gonna make changes inside the this masses, and it will only the thing that will do the learning and the broadcasting by this masses. It will learn the MAC address of this device, the PC1. As you can see, it's broadcasting, and here you will see the drop. It's dropping the packet, and it's reaches to the destination. When I will open this, so as you can see, at G01 interface, here we have the G01 interface, as you can see right now, and here you can see the .1q tag, because it's already VLAN 10 is already created. So this is what we see .1q tag over here, because of the configuration whatever we have done on the switch, that's also carried. Okay, because of that, that's all identities that's a carry through, and it's encapsulated. The encapsulation happening over here in order of flow. It's encapsulated the .1q, and it's transmitting to the gateway. When it by broadcasting, it reaches to the gateway, and as you can see, the destination 10.0.0.1 through this source, which is a 10.0.0.2. And when it reaches to the destination, sorry for that, when it reaches to the gateway, it will flip the whole thing. Once the source MAC will become the target MAC, and the target MAC will become the source MAC, which he want to learn, that will flip. So the source IP, as you can see, at the 10.0.1, which is the gateway IP, and the destination IP is 10.0.2. It's flipping the game, and it will come with the ARP reply. When it will come through this switch, so the switch will learn the gateway MAC address. By going, it will learn the PC MAC address. By coming, it will learn the gateway MAC address. Let's see. Now, this time it will not going to be broadcast, because the ARP reply always in unicast. Remember this. Now, as you can see right here, as you can see right, this mark, that's a good sign, because this is a successful ARP. So when we see, has the all information like the 11.45, this is the its own, and 5A02, this is the gateway, a MAC, right? Okay, now what we see, the ICMP was waiting for this particular MAC address for which is which is possible through the ARP. So the ICMP will, instead targeting this particular MAC address which was targeting initially, it will target this one. So the ICMP request, when it's clear the route, the ICMP will clear the ARP will create the route, the ICMP will initiate its process. So as you can see right here, the ICMP is going, and it will drop because it doesn't know what would be the next hop and what would be the next clear path. So again, when it drop the packet, this is a one packet drop is over here of ICMP. Okay, ICMP send the packets of the 100 bytes of the packet size. If I will open it and I will go inside there, you will see there's a TTL 120 byte. Okay, that's all information that you can see. This is the IP, the TTL is right here. This is the, remember this is the as you can see, Pro 0x01. Okay, and this is what we call, on the basis of this thing, it will going to be changed when it will come or drop. Okay, so what about this ARP request? When I will check this thing in the same way with ARP, so always remember this, there is a ARP which is initiating this, so the hardware type would be like 01. Okay, operational code, yeah, here we have the operational code, that would be always 01. When I will go again, so when it will reach and try to learn the MAC address of the next hop, because what it will do, why it's going to the next hop, let me tell you. Because of when the ICMP is coming over, the ARP was telling to this particular router, hey, this is the MAC, I'm stripping off the MAC address and here's the IP address of that particular target where we are looking for, and let me know the which interface I have to go. So the router one is telling, hey, this is the interface for next hop, you have to go through this interface, okay, for the next hop. Now the ARP will know the IP address of this particular next hop, so it will initiate. If I will check this out, so as you can see, the target IP would be next hop IP, and the source IP is its own IP, but it doesn't know. Because of that, it's a broadcasting. As you can see, the broadcasting address, the target MAC is a broadcasting MAC. Now it reaches to the destination. I will go for the next hop. It will flip the game. Now it has its own MAC address, which is the source MAC address, and the target MAC address, which is the G00 interface MAC address. And the source MAC is becoming the target MAC, and the target MAC is like, it's flipping the game. Actually, the source MAC is right here, the 192.168.1.2, and target MAC is destination MAC is 192.168.1.1. So let's see what happened. We will sing click good sign over here, and now because of that, the G00 knows the IP address of that, sorry for that, the MAC address of next hop. So again, what we see, the ICMP will initiate itself because of it was looking for the MAC address of next hop. When it will know the 4 identities, always it initiate itself. So now ICMP has a 4 identity need of the 4 identities: the source IP, destination MAC, and the source MAC. So now it knows the ICMP know this router to G00 interface MAC, so it will initiate. While before initiating, there is a few STP messages who check the interfaces. Is there any kind of collision or any kind of storm or creating itself, or it's a kind of prevention method. So it always emit, it always send through their interfaces. So we have to just wait, and once it's finished, so we see that will check the reachability. The ICMP will send itself and check the reachability, and again we will see the one packet drop because of there was the next hop MAC address or destination next hop destination MAC address missing. Now as you can see, the ICMP request initiating from this because of it, here we have the MAC address of this next hop. So what we see, there one packet will drop. Now it knows the MAC address of this hop and the MAC address of this hop, but doesn't know the next hop, so it will drop over here at the router 2G00 interface. Let's see. Now in the same way, it's a, if I will click over there, so as you can see, let me go back over here. Now as you can see right here, the ICMP is dropping and instant new ARP is initiating itself to learn the next hop, because the ICMP, when ICMP is coming over here and telling, hey, this is the IP address and I want to go to this destination. For that reason, so ICMP has its own IP address and of the PC1 and the destination IP address. So it tells to the router, want to go this place. So the router will check here their routing table and tell this is you have to go to next hop by this interface to reach that destination. So this is what, for that reason, they only know the next hop and they doesn't know about they don't know about the next hop MAC address. So it will initiate a new ARP request to learn the particular MAC, next hop MAC. So as you can see, it's initiating and coming back. Right now it's initiating over here. The same thing which was happened over here, the same thing will happen. So first it will broadcast and then it will reach and flip the source to MAC, and the whole thing will be changed. The source become destination become a source to learn that particular MAC. That's coming back and telling to the router, hey, this is the MAC of that next hop IP of that interface. So again we see this kind of HTTP messages, and this is what happened always in between this during this thing. We see there's a DTP also, dynamic trunking protocol. Okay, so yeah, now we have, okay, so now you can see the ICMP initiation process is going on, and where it's know the MAC, the destination MAC or clear MAC, it will reach to that destination, but where it doesn't know the next hop and the whole thing, so the ICMP will drop, because it's always looking for the 4 identities. So the same thing will happen while going down. By sending the MAC, it will the router 3 G00 interface MAC address will learn through this switch 2 or switch 3. So this is what happened before. The same thing will going to be happen again. Now switch is learning and broadcasting, as I told, the behavior of switch, and it reaches to this destination, and it will bring it back the MAC address of this device. In this situation, in both going and coming back, the router will learn the MAC address. Now it's updating their routing table. It's updating his MAC address table. The switch has MAC address table. So again the HTTP we see, and the HTTP will work always in between this all thing. Whatever is going on, that would happen within a 2 seconds, and whatever we are doing, that's taking too much, but because of we are breaking the whole thing. Okay, so here's the whole catch about this. So again you will see here we have the ICMP, and it's going through each and every hop, and now we have the ICMP. This is what is happening, is what we call, this is a ICMP echo request, which is the 100 byte of echo request, In PCs we see 32 byte, and in Cisco's other 100 byte of that echo request that we see reaching and coming with the echo reply. Okay, so what we see, as we have seen, there was 3 packet loss at each and every hop. So the out of that all, we will see the 75 of success rate. Now, as you can see, the ICMP is a successful ICMP request. So when I will see there's a, as a result, the 75% of loss. Okay, the 3 packet loss over here. Okay, out of 10, send 10. Okay, 75% of packet loss. Okay, now again I will ping. It would be 100% because of it already learned the whole path. So as you can see, it's a reaching the ICMP, successful ICMP request is going on, and it's coming back. This is what we are looking for. Okay, so there was the whole thing about the packet loss and the flow of the data. If you want anything in detail, let me know. I will break down and we will learn further. Thank you.